hosting this panel, delighted to welcome Dr. Peter Nieuwenhuizen from Change Chemistry. So Peter, over to you.
Thank you so much. Thank you so much. This is a wonderful, wonderful opportunity. Really nice to be here. Change Chemistry is a partner of World Biomarket. We have about 125 members, going from some of the people over here, BASF, Millipore, Merck, Dow, all the way to the other side of the value chain. So companies like H&M, Apple and Target, and together we're trying to get rid of harmful chemicals in the value chain. The heavy hitters are over here. I'll let them introduce themselves, starting with Ivana Krkljuš.
Thank you. I also wish a warm welcome to everyone. Thank you for joining the panel. My name is Ivana. I am a chemist by training. I'm working for BASF for the past 14 years. I am not a biotechnologist. Actually, I could tell you more about battery material, cathode material technology than about bio. But on the other hand, I'm actually covering the BASF strategy for green transformation. I was also working in advocacy for bioeconomy. Market pool is also one topic that I'm closely related to. Thank you.
Thank you, Ivana. Shaun Russell.
Yes, thank you for giving me the opportunity to speak today. I really appreciate it. Nice to meet you. My name is Shaun Russell. I'm Strategy Manager for the Sustainability and Social Business Innovation team in Merck. My background is in regulatory, but also in environmental science. So I come at a little bit of a different capacity to the other panelists here. And I'm really looking forward to discussing with you how we address these really important topics today. So thank you very much.
And of course, Laura Kherbeck.
Thank you. Thank you very much for the opportunity to speak to you today. My name is Laura Kherbeck. I am the Product Stewardship Director at Dow for our industrial intermediates businesses. I've been with Dow for 13 years. I'm a chemical engineer by training, but I never worked anywhere other than Dow. I'm one of the drivers of Dow's Safer Materials strategy, which is our latest and greatest.
Which is very relevant for today's conversation. If I may have the first slide from Change Chemistry. Yes, there we are. Detoxification and defossilization. So obviously we need to talk a lot about decarbonization, more precisely about defossilization. This is very important, but we cannot forget detoxification, which is also one of the legacies of our industry, and which is something that Change Chemistry, as I told you already, puts a lot of emphasis on. We have 125 members. If you are not yet a member, and if you care about both the defossilization and the detoxification of the chemical industry, you should report to Jenny here in front. Maybe you can raise your hand. And I would assume that also Rui, I've got a bit of a light against me, is somewhere in the audience. Rui Resendes. I guess he's talking to new members. So talk to them. In order to register as a member. And I'd like to see the next slide, because what we do not want, if we get the next slide, thank you, we made this very simple 2 by 2, but it can be very helpful. So on the one hand, we have defossilization. We're on the way from no to yes, but of course the nightmare that we could end up is to have a biobased PFAS or a circular PFAS. This is not going to help us to become a sustainable industry. We could also have some very harmless chemicals that are not yet defossilized, but they will get there because the industry is working on systemic defossilization, and that certainly is something that I think the panel members will talk about. So the first question that I would like to ask the panel members, given that there is so much emphasis now on defossilization, how are your companies dealing also with the detoxification? How do you balance the two? And are there perhaps already some win-wins? And I'd like to start with Ivana again.
Thank you. Well, I think we cover basically the both topics, and I think detoxification is something that is longer actually on the agenda. and was in Europe at least mainly driven by REACH regulation. What we do also, we have basically a system of steering our entire portfolio called Sustainable Solution Steering. This is something that we apply now over a decade. It is a method that is also externally certified. And basically this means that we go throughout the whole portfolio, we break the silos in terms of teams who are looking at different products. They are sitting also at the same table, from regulatory people to sustainability to product management to strategic marketing, and are evaluating these products basically on a yearly basis. And when something is identified based on the measurements that are being executed according to the needs of different products, that there is a potential actually for harmful substances, then these products are classified and they get also a certain sunset date. On the other hand, basically decarbonization is of course a topic that is coming now from a different angle and more from, I would say, sustainability side, more from European Green Deal. But our approach is, once you define something that is harmful, then those products are basically not prioritized to be utilized for placement with different marketing claims related to sustainability. So basically we have an offering of biomass balance products where we utilize biomethane, for example, as one of the feedstocks. And if those products are planned to be outsourced from the portfolio at a certain point of time, then they can never actually be qualified to
take share of the biomethane that you're using. Yes.
Exactly.
Okay, very interesting. Thank you. Laura.
You know, Dow and BASF are quite similar in our approach to this, right? So how you look at the portfolio and how you make plans to phase out, etc. I think what we've also done internally is we've made it extra difficult to actually bring a molecule to life and to market, right? So we have our toxicologists sitting at the same table as our R&D folks. And essentially what they do is they utilize predictive toxicology tools. So we're really big on non-animal testing methodologies, right, to predict certain hazards of molecules. So they look really into the future of a molecule, what it could be based on its structures and certain properties, in order to avoid any regrettable substitution, essentially. So triaging the portfolio right into seeing where we have issues to address and where we do need to find solutions, really sitting together and looking at that predictive toxicology field.
Do you already have specific examples where there's a win-win? We defossilize and we detoxify. Anything that you introduced recently?
Well, actually, Ivana mentioned, but the mass balance approach, right, where we take in bio or biocircular or circular feedstocks in, we also have a similar concept that you cannot give it a sustainability attribute if it has a safer materials problem or substance of concern present, right? So we have a few surfactants that we launched, right, that essentially do both, right? We have renewable ethylene oxide, so it's still a ethoxylated chemistry, but it's really the next generation of ethoxylated surfactants which have a much better environmental and human health profile. This is just one example.
And they are defossilized, but
yes.
That's more through the systemic approach,
correct.
so to speak. Yeah.
Correct. And the difference, I think, one is we have regulation guiding us on carbon a lot, right? So we know we need to drop our energy intensity, reduce emissions, sequester carbon. But for safer materials, we have had limited guidance, I think, from regulators. A lot of times companies have been left to their own devices. So we had to do this work internally with our internal toxicologists, et cetera, even before regulators did anything about it.
Interesting. Shaun.
Yeah, and what Laura mentioned there about triaging the portfolio definitely resonates with us. You know, us bringing in Merck, if you're not familiar with the life science industry, you know, we set a lot of solvents to researchers, and they need to do a very important job in order to bring their work to benefit humanity. We need to bring both of these realities together, and the way we do that is, first of all, we look at our portfolio, definitely the top sellers, and we use Chem21 as our guiding star for this to identify, you know, recommended chemicals, or they could be hazardous chemicals or highly hazardous chemicals. And we use that then to guide us in which ones we should be looking for dedicated alternatives. So these are different molecules in which, you know, we need to offer to our scientists so that they can begin using safer alternatives. However, when we look at the ones that are, let's say, recommended, like acetone, for example, we consider the entire life cycle of what we're looking at. Acetone, for example, you will see hotspots in areas such as crude oil extraction and the processing of that, like the distillation. An example of where we are doing this is we've identified a source for acetone, butanol, and ethanol from whiskey draft. This has resulted in a 60 to 80% reduction in carbon emissions, which has really resonated with our customers. For the dedicated alternatives, I'll use our example of styrene as a substitute for NMP and DMF, though there are other trade-offs to do with this, such as cost competitiveness, scale. For styrene specifically, there's a higher boiling point. So even though we have that very nice 2x2 form here, I think a lot of our customers will be looking for extra matrices on that.
Cost is obviously typically an important element, as is performance, right?
Absolutely.
So if you look at that, so where do you think you've really hit that win-win? Is there a terrific example?
Yeah, the acetone example I gave you, when you start to source this from a bio-based area such as whiskey draft, it actually naturally has a lower benzene limit, which directly makes it safer to handle in the lab. And similarly with styrene, this comes from cellulose, so it's a natural carbon reduction compared to NMP or DMF. So there are some win-wins there, but there are also trade-offs that we need to be very realistic about.
Yeah. Okay. Thank you. Ivana, do you want to share any particular win-wins from BASF that you're proud about?
Well, I think maybe I don't need to go to product examples, but I think in principle regarding how we handle the topic, I want to mention something that was also brought forward by the European Commission as well, as safe and sustainable by design concept. So maybe for the ones who are not familiar with that, and why I'm mentioning this is because I heard a lot of presentations here. You work on different concepts, different products, but at the end of the day, before something gets identified as being toxic, I think you need to take a couple of measures in advance. You need to think that through, because once that's being confirmed, then it's basically already too late, and you have developed all your process for nothing. So yesterday, I also, in a couple of presentations, there was again and again this statement, you need to start from the end. And this is something that I was missing a little bit also in the discussions. There is a lot of talk about process optimization, which would then, for example, lead to defossilization or reduction of scope 1 emissions. Then there are also different molecules being introduced and so on. But I think this part, this specific part, at the end, all of this ends in the products. All of this ends to basically with consumers. And I think that the ones who are developing need to go also through that logic a little bit and understand what happens with this product. What are also concerns that might pop up along the value chain, that I don't lose actually my time in developing something and then I cannot basically take it back.
It's a good point, and it actually points to something else. We have safe and sustainable by design. We have awareness within companies that if we develop something, we should already understand what it might do in terms of harmfulness, in terms of toxicity. But at the same time, we have an existing portfolio which started probably 100 years ago when we had the presumption of innocence, right, for chemicals. I think this is how the PFAS problem came to life. We assumed it would be all right. So how do we deal with that? Because that probably has led to a huge amount of distrust amongst consumers that are now facing, hey, there is trifluoroacetic acid in my bread, it's in my drinking water. What are we going to do about that as an industry?
And I know I told you earlier that I don't want to go into that regulatory space for this discussion, but it is a question of policy. It is far too easy to bring a molecule on the market, even under EU REACH, which is perceived as the gold standard, right, of regulations. But all you have to do, you register, you propose some studies. Maybe 5-6 years later, when ECHA looks at your dossier, it goes like, well, you need to actually test this for reproductive toxicity. Why does it have to be the case? Why don't you need that full data package or demand those predictive toxicology results from the companies, right? If you're putting a new molecule out there, you need to do your homework. And regulators and policymakers absolutely need to help us with that. And hold us accountable.
And is this something that Dow is advocating? Are you saying, listen, it is too easy for us to bring things into the market. You should regulate not just us, but actually the whole industry?
I don't know if we are, but I definitely think we should be.
Okay. What's your view on that? Because that's a pretty, I would almost say, revolutionary view from a chemical company. Shaun.
Okay. So, no, absolutely. And we see this, as we discussed outside, regulations are often they're let's say, follow after customer expectations. And we see this really come out of customer expectations. So, we are seeing AI and machine learning really take precedence in this area, such as, it's quite good now at predicting sensitivity in skin, actually better than animal testing. So incorporating that into early development, I think can, number one, you have better results than animal testing, and you also get to avoid that unnecessary animal testing as well. So I think, yes, policy has a role here, but I think technology also has a role that we need to keep in mind.
Interesting. Thank you. Ivana?
I think we are also, to a certain extent, putting a lot of burden on new developments, and we are trying to fix something that was there for many years, and it needs to satisfy a lot of requirements. On one hand, I think it's also difficult to predict, and why I'm stating this, because I was also previously in one of the roles that I had also within the company, when I had a close look at and work with the ones who were evaluating some of our products, even if authorities try to cluster these products together, the differences in the production, the differences also in the purity, in the quality of the product, also in the process itself, are bringing at the end also different classification of the end product. So read across is also very difficult. The aspect that I'm thinking about is maybe if it's possible to use to a certain extent, or maybe even develop further artificial intelligence to benefit from existing data, from existing results, and then maybe predict also future problems.
Yeah. Is it not asking too much to expect chemicals to be completely innocent in the functionality that they bring to us? We seek something, a cleaning functionality, but of course that functionality means, well, it's doing something. Are we? Is the best the enemy of the good, and will we not be able to introduce anything anymore? And therefore we will be stuck with the old stuff that we really know is bad. Anyone?
It's a question again of trade-offs, and I have an example to use. So we have some compaction surfactants. I know I keep going to the surfactant space, and essentially what they do is, first of all, they require less surfactant per final formulation. They're more dense, so you need less packaging, right? So there's lesser amount of water, and the most important thing is they get the job done in your washing machine at lower temperature, faster cycle, so much less water. Right, so all those great benefits, and you're like, well,
fantastic.
this is the deal. This is fantastic,
Yeah.
right? We were not able to eliminate the usual concern of surfactant. We were not able to fully eliminate aquatic toxicity, and we were not able to eliminate the eye irritation, which is what we actually sought to do, right, to get that fully safe product. Yeah. And we have our biggest brains and the best brains on this problem, right? Yeah. And they just cannot find the answer. So what is the right answer, right? What are the trade-offs we're willing to accept? Yeah. can we mitigate certain hazards in favor of a better environmental profile? And that's we don't have the answer to that. You know, we're searching, but we just, and it's a question for the innovators of today, right?
Yeah.
For the dedicated alternatives that we, provide to the market, I think providing them to the market is not just enough. There's not all chemists or our customers are necessarily educated in toxicology. So education is, I think, a really key area, particularly for the future of scientists who are using these materials, may not, be able to know how to use the alternative. So how Merck is active in this space is with our partnership with Beyond Benign, which is a multi-million dollar partnership. We've impacted 225 universities and 1.5 million students in integrating greener chemistry into their education. I think this is a really key future action that we can take in the short term to make sure that we're not still here when we have this conversation in 20 years.
Okay, thank you.
I think to a certain extent as consumers, we got spoiled. And I think that we want always more and better product and better function. And there is this hunger actually to always acquire new things, which is what is then pushing also the industries to compete with each other and to try to satisfy this hunger. On the other hand, I also think that it is fairly difficult for consumers to judge, especially regarding safety. I think when you mention something like toxic, there is just fear. But I think that most of them cannot comprehend this information. Even if you see the pictogram, I wonder how many understand.
Yeah.
And if I see also now what is happening with this hype on transparency and digital product passport and so on, there will be a lot of work to be done.
Yeah.
But will this data help us? Will they make us safer? I'm not sure. I think most of the people, even if the trained chemists cannot really understand and grasp on all this, how a regular consumer can do that.
Yeah, you're sort of looking at a world where maybe you say, well, we need to redesign it in the sense that if we can keep the harmful chemicals in controlled environments, for example, cleaning metal sheets, we know it doesn't go into runoff. Okay, maybe that's an environment where we can handle harmful chemicals. If we don't know where it will end up, in the case of surfactants, clearly in the case of PFAS, in the case of plastics causing microplastics, and we don't know how it will disappear from the world, clearly that is something that we can't take responsibility as an industry to let it get out of our hands and out of our control. But that's a different world than where we are, and it is not just the chemical industry; it's also consumers, and certainly also policy that needs to help with that. I'd like to end this panel asking you. There's a lot of innovators in the room. There's a lot of investors. There are startups and scale-ups. If we look at the detoxification, where are the opportunities? Where should people spend their time and their money and resources to create the better world that we're after? So maybe just a few ideas from each of you.
I'm lucky I get to go first, so I get to state the obvious. We absolutely need PFAS replacements. Absolutely essential. So I think the more we can innovate in that space and move away from those molecules, that would be ideal. I think my second part, and Peter, you know this well, it's the year of the solvent, right? So we are really looking at the type of solvents we use. They've been flying under the radar for a while. And the challenge with solvents, they're very high volume, right? And they're usually in industrial settings, but such high volume of very hazardous chemicals like certain chlorinated organic solvents, these are legacy molecules. They don't necessarily have a place in the modern world because we can do better, we're able to do better. And I think we still lack those kind of innovations in the solvent space, right, that can perform as well as the legacy molecules, just with a better environmental and human health impact. So just two examples from my end.
Where do the chlorinated solvents make their way into the environment?
I think poor wastewater treatment management and just I need to think about that one because they're designed to be used in an industrial setting.
Yeah, so in a controlled setting.
In a controlled setting, right? But there is still way too much runoff going into wastewater treatment plants. So we know it's happening. We know it's maybe not controlled to the way that it should be. So that's kind of where I would say don't assume. You know, every time somebody tells me, well, it's a closed system, I question that 10 times over. Yeah. I don't always believe that closed system argument.
I can see that, yeah. Shaun, solvents.
Yeah, for me, happy to answer this question. So scale is a huge issue. I mean, we're looking at, even we looked at one process internally for one of our suppliers and we said, okay, great, we could eat up that entire annual volume with one of our processes. The petrochemical solvent industry is churning out between 100,000 to 1 million tons per year. Luckily, we're lucky to see if any bio-based solvent or dedicated alternative is churning out even 1,000 to 5,000. So there's a huge gap there.
There's growth possible.
We're in a transitionary time, and I think it's a time for investment. Absolutely. The other part is, as I mentioned before, education, and I would encourage any investors to join us in that, as you know, this has compounding value for the future.
Would you recommend any investors or scale-ups to go into alternative solvents, or are you already covering it all? You'll be a fierce competitor of them.
Look, we're happy to see more activity in this area, so it's definitely not an anti-competitive area. It's something, you know, if you have something and it's aligned with what I've spoken to you today, we want to hear from you because it's part of the solution.
And you could acquire it, perhaps. You would be a possibility for an exit?
I'm not at the liberty to tell you who or what we could acquire, but
okay.
Anyway, thank you for the question.
Yep. Ivana.
I would put my bet on raw material sourcing in general. I think that's, on one hand, if we think about raw materials like coconut oil, palm oil, those are all that are applicable to bio-based products. Those are the ones which are giving us a good feeling also, but they also come with other hurdles. And this is something we also didn't talk about, and I also didn't hear during these 2 days. I think the question of sourcing those raw materials, then the question of public perception of the consumer who is either willing or actually even more scared now, independent of if something is toxic or not, but where it's being sourced, under which conditions. I think this is also one big part of this puzzle. And the way to manage this information, to ensure that we have secure supply chain, that we are not doing harm to anyone, but also that that consumer, when he's standing in the shop in front of that shelf, that he feels comfortable when he buys the product, and how he's able to feel comfortable about it. And I think this is something where we still didn't really get our arms around.
Okay. Which is a big topic to get your arms around. Okay. Thank you very much for your insights, for sharing bold visions. I would say maybe we can give an applause to the panel members.